Hi everyone, I'm Jeff Krebs from eyeon Software, and I thank you for joining in on this webinar featuring Fusion and Media Composer utilizing Connection, the conduit between visual effects and editorial. Also on this webinar are a number of eyeon geniuses, including Eric Westphal, who is product manager for all eyeon products, and Blazej Floch, who is a scripting guru and pipeline specialist, as well as product specialist for eyeon products as well. eyeon Software develops a variety of visual effects products, including Fusion, Dimension, Generation AM, and Connection, and eyeon has a very long pedigree in film, television, and gaming. Fusion's tool sets are incredibly rich and complete. eyeon Connection is the companion and conduit between Avid editing products and Fusion. It's an AVX2 plugin that allows for a direct round trip. Prior to solving effects challenges that you may see in your daily finishing, it's important to understand how a node environment works and how nodes open up an entirely new free-form approach rather than being locked into layers. Nodes are for compositing. Nodes are sources, tools, and outputs connected on a logical mind map style flowchart. Tools, or combined groups of tools, can be easily duplicated, instanced, or branched in any direction. The most important concept to understand is that everything can remain on the flow. Even groups which may appear as a subflow are done for the efficiency of real estate on the flow. Note that grouping is not required as a matter of software functionality, which is what nesting is all about. Fusion simply does not require nesting. Think of it as a mind map of exactly what's happening. This makes it easy to follow along and even easier to figure out what a fellow artist or what you did weeks, months, or years ago. Another thing to note is that node positions on a graph have nothing to do with the overall visual result. The flow dictates the order of the processing, which can use the node's position to freely organize and structure your composition. The Fusion timeline is designed for exactly that. Timing purposes for clips or effects, as well as slipping or rolling, and for precise keyframe control, as well for viewing efficiency. Since Fusion's timeline is for timing, moving items around vertically in the timeline has no effect on the composite and are movable strictly for efficiency purposes. So you can do this, or filter like this, without penalty. You also get a rich spline view for controlling your animation curve and comparison purposes. This can involve repetitive animation tasks. Your true resolution-independent composites are simply piped merged through a series of nodes instead of confining layers. Unlike other applications that claim resolution independence, you will never have to pre-transform or pre-comp your sources. As well, all transformations concatenate for continuous pristine results. If layers act as the curtains hiding the details that are nested within, a Fusion node environment turns those layers inside out and lets you easily and logically work behind that curtain. A Fusion node visual effects environment being used for design and motion graphics is truly a different creative working experience. However, with a bit of time in the seat, you will quickly realize that nodes add a level of efficiency that's impossible to achieve if you're confined into layers. The other secret weapon of Fusion is Real 3D. Creating motion graphics from a 3D comp will open up a new world of visual control in your design. We'll cover a lot of 3D in just a little while. Let's begin in the Media Composer and start with a simple rostrum move, also known as a Ken Burns effect. This effect is all about speed, image quality, and deep control. The reason we're beginning from here is to simply introduce the features and interface of eyeon Connection and the use of Fusion in its simplest form, will very quickly add more complex examples after this introduction. By simply applying eyeon connection to an imported clip, still, transition, layers, or even a blank filler space, and selecting how many layers I want to use, I've created a conduit to Fusion. We'll discuss the other buttons later, but I just need to click Edit Effect and Fusion is launched, and my still is transported to Fusion. Notice the pink node. That's the saver, and that's directly connected to the Avid timeline. The timing is identical to the timeline in Avid, and the project setup matches perfectly to Avid's settings. Because my Avid is locked in a video resolution, I probably want to use a high-resolution version of this still. Fusion, being true resolution independent, allows me to work with any sized images or clips. This image is well over 4K. And I'll select the background tool. The background tool automatically matches the Avid project settings, in this case 1920 by 1080 because it was created through eyeon connection. Also note, the background tool can be uniquely defined via the preferences and can be changed at any time. By simply connecting the red outputs together, we create a merge, which layers your clips together. Now let's control that Ken Burns move. Let's start by animating the photo's size over time. I hit the play button and you instantly see the results, as you would expect to see them at full speed. Let's do the same with rotation and position. What you'll notice is when I view the spline curve, I can continue making curve adjustments without stopping the player. This is the way to build a Ken Burns effect in its simplest form. Now, I simply hit the render button and I'll switch back to Media Composer where you see the final results. If my effect is still processing, I can continue editing and watch the update simply by moving my timeline bar over the clip. Since it's complete, here is the result. Other features of connection include the ability to keep layers and transitions intact. Layers in Avid equal merges in Fusion, except for one difference. The footage remains the same, but the control over your layers and the pristine results will be very evident. As well, the ability to create versioning within connection brings an increased level of efficiency. Simply create new versions at the touch of a button and then see the results of the different versions that are available directly on the Avid timeline by using a simple slider adjustment. Now that you've had a bit of an overview of connection, as a team, we're going to focus on the creative and powerful use of Fusion. One of the most interesting features of Fusion is the ability to use a hybrid of two-dimensional and three-dimensional compositing in your work. 3D compositing has been more than just a buzzword for quite a while. For Fusion, it's actually been 9 years since 3D compositing has been added to the software, and it really performs well. It's important to understand that a 3D comp takes a bit more time to get your head around, but once you master it, you'll find that compositing that you normally would have done in a 2D compositing environment are far more interactive and dynamic in 3D. To introduce some basic requirements for 3D, the first thing you'll need is a display card with a decent GPU. I know that most people are using the Quadro products, and just so you know, you'll get incredible price performance from the GeForce product line as well. With that, setting up your 3D environment will always require a source being added and not limited to the following methods. As well, you'll require at least one camera and one renderer. Renderers do a number of things. First thing to note is that Fusion has a software and an OpenGL hardware version of the renderer. There are benefits to using one over the other, depending on the situation. Shadow control certainly looks better in software, but the speed is always better in hardware, and control over camera optics like depth of field as well. Renderers render more than red, green, blue, and alpha channels, which leads us into deeper image channels that you might not be used to. This includes Z channels, normals, IDs, coordinates, and world position paths. Everything else, including geo, text, shaders, lights, and textures, are there to help you creatively build your 3D comp. What we'll be working on today is the tag section of a fabricated local spot. Eric, Blazej, and myself will be utilizing Fusion for 2D and 3D compositing, as well as animation and internationalization and versioning. In this section, we'll speed through an overview of some simple 2D tools that are frequently used. The purpose of this overview is to review some standard practices and to set scene sizes and create merges for a quick result. In this case, we'll create a real simple old school logo. Like most comps, we'll begin with a background. I'll color it red and take notice that the size in the image tab is 720p. I'll set the color depth values to 16-bit float. Note that my frame format prefs are set to 720p. Therefore, any new tool I add will follow suit. This can be set in the global preferences, but of course this can easily be changed at any time by modifying it manually or using a script. Let's add a Text Plus tool. Notice when I added the tool with the background selected, the merge was automatically added. There's lots of flow tips and tricks available in the introduction tutorials as well. So let's type the name of a company. And I'll use a preset style to change the look and size. Next, let's add another Text Plus tool. This time we'll create a carefully designed logo shape, carefully selected from Wingdings. Let's merge it on top. As well, we'll make some modifications to the layout transformations. And let's use a rectangle mask to modify it. And take the transparency down a bit. The Fusion Mask tools are very flexible and let you chain unlimited mask nodes together to create a run of masks. Again, there are tutorials on this, and once this webinar is posted on YouTube, there'll be a link to all the categorized Fusion tutorials listed in the About section. To equal things out, let's quickly connect a transform and set it to flip horizontally and merge it in, and that'll create the mirror image. Voila! Take notice that the mask source used into the Text Plus tool, as it allows you to only have to modify the left side and the right side follows suit. That's because we're making the modifications near the beginning of the flow and viewing downstream after the transform. That's one of the great benefits of Fusion node compositing. Adjust one node while viewing the other. Next, I'll use a brightness contrast, which I'll modify soon by adjusting the value, and I'll add an effect mask input. This is done simply to create a pill shape, using a rectangle mask and rounding the corners to achieve this nicely. And adjusting gain and the effect mask will cut the hole. Remember earlier I mentioned branching tools and masks? Well, let's do that this time for another purpose. I'm going to add another background tool. This time I'll enable the gradient to add shading through the use of a channel boolean. In the channel Boolean, I'm going to use an add operation, which sole purpose is to add color values from one channel to the next channel. Finally, let's add another brightness contrast and lower the gamma to decrease the mid-gray tone and add some fake depth. In the next section, Eric will introduce you to 3D projection techniques to complete the product shot in our tag.
Thanks, Jeff. So we need to prepare a simple three-dimensional model of this week's special sale of our client. Of course, it would be too expensive to model the notebook in a 3D program. So the client provided us with this photograph of the product, and we will solve the task with simple projection techniques. First, let's knock out the background on this photo by adding a brightness contrast tool and masking it by means of a wand mask. Observe how the wand's input auto-connects to the upstream tool. Let's also limit the wand's range by adding a rectangle mask set to invert. Adjust the wand's range to fit and bring down the gain for RGBA and the brightness contrast. Add a crop tool, view it and click on Auto Crop. Now it's time to move into the third dimension. Luckily, the notebook's shape is rather simple. 2 fusion shapes should do just fine. Let's make these into boxes and roughly adjust to get something that resembles a notebook. Next, we need a camera to project our image through. By default, the camera is set to display an image plane. Disable this and enable projection instead. Make sure that light is turned on under the view and adjust the camera's position. View the scene through your camera and keep adjusting the position interactively. Now you can fine-tune the size of the 2 boxes. It's also a good idea to lock your camera to prevent any accidental changes. Almost done. This could already be used to believably introduce some motion, but we still see black corners. To remove those, we need to add a special type of material to the boxes called a catcher. The catcher is specifically made to obey alpha channels in projected textures. When we connect the catcher, the projection disappears. This is due to the fact that the projection on a catcher material must be a texture, not a light. Any projector or camera in Fusion defaults to projecting light. Change this to texture and everything falls in place nicely. Let's add a point light to the scene. As you can see, the notebook does not react at all to the light. That is because the catcher material does not have any lighting model by itself. To get around that, we simply add a blend shader directly after the catcher. Shaders in Fusion can be concatenated, so you can build highly sophisticated shader trees this way. Let's add some screen content we prepared earlier by using a material merge and a UV map to exactly specify its position. Add another camera and animate its position and rotation. Pack shot done. Of course, this can be pimped by adding reflections to the keyboard, as you can see here. If you require close-ups, you could take a different approach by painting out the letters on the keyboard and using this image to displace the actual geometry. While both approaches are simple to achieve in Fusion, it would go beyond the boundaries of this webinar to explain them in depth. These will be covered in upcoming tutorials.
In our next section, Blazej discusses background creation using geometry import, expression control, and 3D particle systems.
Thank you, Jeff. In this composition we will create this 3D background with balloons. First of all, let's import a 3D model of the balloon. We're only interested in the mesh, so we disable all the other options. And here you can see the imported FBX model of a balloon. As you can see here, it's centered within the origin. Now we will make a little shader for this balloon. We start off by a day sky node and color it red, apply it to a sphere map, and create a little cook turns shader. Then we use a reflect node with a follow to create this rim light effect. For the tail I used a shape 3D node, set it to cylinder, and then I applied the bender node. The bender has a little expression, which is a simple sine curve. We control the frequency and amplitude of the sine, and you can visualize this in the spline editor. On top of this, we create a little bender, but set it to twist this time, and use a different cosine function, so we get a random looking motion. We merge the tail of the balloon, and here we got the result. The balloons will be replicated on a 3D particle system. We used one with a box region. The number is set to 20, so it will create 20 particles on the initial frame and 0 on the next one. The lifespan is quite high, so it stays alive for the whole animation. Then we added a little wide velocity, so the balloons go up. There's also another turbulence node. Let's visualize the particles with some good old Coopers. But we're only interested in the points, so we'll switch this back. And now we can create a replicate 3D node and input the particle system as the main input. And the balloon is the first input. As you can see here, we got all the balloons and the positions of the particles. In order to create different colored balloons, what we can do here is not to recreate the whole shader, but use a channel 3D boolean and swap the channels. This will create a green and a blue version of the shader, which we can then assign to the balloon model. Now we can use the second and third input of the replicate node. And you can see all the balloons replicated. We switch to randomize and randomize until we're happy. And all it's left to do is give it a little jitter and time so that the tail animation looks more randomly. I already created this replicate node down here. So the next thing we will do is create a little light dome. To visualize this, I created a little shape 3D set to a sphere and connected its position to the point light position via simple expressions. Then I used the duplicate 3D node, and as you can see, I rotated it around Z. Then I used another duplicate node and rotated around Y. So with this dome, we simply replace the ball with the light. And as you can see here in the reflection of the balloons, we get different point lights reflecting in the balloon now. Then I added a disk made of a cylinder and created a spotlight for the shadows. rendered, it looked something like this. For the background, I used one of the templates called Spot Ground. This will allow you to control very smooth backgrounds. On top, we did a little vignette, color correction, and here's our result.
Next, Eric discusses 3D mesh displacement driven by a noise generator to create an alternative background.
Another graphical element in this shot are the little sunny icons in the background. There are different ways to achieve this effect, but in this case we used a mesh to align the icons and also displaced that mesh with a fast noise tool. So we need a loader loading our icon and connect it to an image plane to bring it into Fusion's 3D space. Then we create a shape 3D, which will be used to be populated with the icon. A simple plane is fine in this case. Let's set it to wireframe so we can judge the subdivisions a bit better. After the mesh, we add Replicate 3D and connect the image plane with the icon to the green input. Just for reference purposes, we can connect the base mesh to the 3D merge downstream. Let's adjust the subdivisions on the base mesh as well as the size of the image plane. To add some motion to the setup, we connect a Displace 3D to the base mesh and use a fast noise to define the displacement. As you can see here, the motion on the mesh transfers nicely to our sunny icons. We can now connect the setup to the rest of our scene.
And next, Eric will work on the price tag, focusing on animation techniques while working in Fusion's rich spline editor.
Of course, everything has its price, so we need an animated and easy to update price tag as well. In fact, this could be done with just a single Text Plus tool. As you might have seen in the Text Plus tutorials, this tool comes with 8 shading tabs. To save some time in this demonstration, I already prepared the values and activating the shaders shows the desired result. As you can see, adjusting the individual elements is pretty straightforward. Let's add an image plane to move into 3D space. A transform 3D is used to animate the image plane's position. Let's add some sort of dynamic vibration at the end by modifying the motion in the spline view. Advance in time and add another keyframe either in the display view or in the spline view. Select these 2 keyframes and choose Duplicate Ping Pong from the context menu. 5 loops should be sufficient in this case. Zoom out, select the new keyframes and use Shapebox mode to apply some dampening. Finally, let's speed the entire thing up. Nice and dynamic motion. Let's add our camera and renderer and we are ready to go. Unless we want to add some improvements. Like separating the price tag into the actual price and the label. To do so, we copy the Text Plus and paste an instance. Then, in the Instanced tool, we de-instance the enabled checkbox from all 8 shaders. Now we can switch off the numbers in this tool and switch off the background in the other one. Add another image plane and merge them. Let's move the actual price forward a tiny little bit. And why not add an expression, so that the further the tag is away from the center point, the further apart the price and label are. As you can see, the creative possibilities are endless, and I could go on and on. One more thing about this setup, it obviously adapts nicely to any price. Which brings us back to you, Jeff.
Blazej will now discuss complex versioning of the tag made simple by utilizing Python scripting to drive render results.
Thank you, Jeff. At this state, the client is happy with the overall result. Now we have to compile 3 different products with 2 different campaigns in different languages. That sounds like a lot of work. The client gave us a spreadsheet with all the different versions and products and texts. Let's export this as a CSV file. Now we have to set it to tab delimiters and UTF-8. Fortunately, I'm not only lazy, but also know a bit of programming. So I prepared this comp control, which is a Python script that loads in your data and is able to control and create comps based on this data. Let's see how it works. Here you can see that we have different names for the different products. I prepared a composition with the name of the product and made some special notes for the text and named them accordingly. So this is the features. As you can see, features has a styled text, that's what we want to change. Similar for promotion, which has also a styled text. And the price, again a styled text. Now there's a different control called theme. This is a dissolve node. I prepared both backgrounds for the product. I even was able to do a foreground balloon here. And then we can switch with the theme mix between these 2 backgrounds. We also have a safer called safer1. That's basically the same setup for all 3 products. I named the comps according to the products, so now we can go back to comp control and basically assign the columns accordingly. First of all, we need to set the source composition, which is uload_comp, and where to save it, comp.save. These 2 special nodes are required for every process. Now let's duplicate this column for the safer. We call it safer1 clip. So this will be where the frames will go. Now our price is quite okay, but it is the style text we want to change. Same applies for the promotion and the features. The campaign is our theme mix control, but we have to convert it to integers first because we can't use text. There's a convenient little function here called convert to int. This will do for now. Now let's handle the paths. We have some variables predefined which are called comp source for the comp source path, comp dest for the comp dest path, and safer dest for the safer destination. There is a quick replace text function which will do most of the work for us. We replace the current variable and set the paths accordingly for the comp and also for clips like the safer. Once this is done, let's save our progress. All that's left to do is hit the apply button and grab a coffee. All the frames are rendered, and also we have each individual composition, so we can even adjust them individually. Now let's have a look at our frames. Let's switch to generation quickly. I will group the products here. And now we can see all our finished animations and switch between the different versions. That saved us a lot of work, didn't it? I think it's time for a coffee now. So over to you, Jeff.
Thanks, Blazej and Eric. Let's finalize this comp by providing some post-processing through the use of existing templates that are downloadable from eyeonline.com. In this case, we'll take a look at our lens flare selections. Now, if we backtrack a bit, you'll notice that we have a camera move in 3D space, and you might want to add a lens flare after the render. Sure, you can track the moving laptop afterwards and simply connect the lens flare, but why not just use the 3D data that already exists? That's what the 3D locator tool is for. Its purpose is to transform a point in 3D space to a 2D coordinate. Let's do exactly that. First things first, let's select 3D locator and branch it directly off the camera. Similar to tracking, as long as the node is on the flow, the data will instantly become available. Let's label it for easy identification. We'll call it locator lens flare. Now, view the 3D merge downstream while using an interactive pick tool to select the 3D space. Now, in our second viewport, let's add a lens flare after the render. Select the center position of the lens flare and right-click to connect it to Locator Lens Flare Position. And there you go. Data received from 3D is mapped onto a 2D coordinate. Of course, no tracking is required. And if you modify the 3D locator's position, the 2D coordinate will update accordingly. Pretty cool. In this short amount of time, we covered many subjects, and we only scratched the surface of eyeon product capabilities. Thank you once again for spending a bit of time with us. A reminder, if you need help on the use of specific tools, you can find the Fusion manual at manual.eyeonline.com. To evaluate Fusion, fill out the form at eyeonline.com/eyeonevaluation-download. The link will be available in the About section once this webinar is posted to YouTube. With that, we would like to open up our text chat line where we will take your questions and comments.